Question 6. This question is about period 3 elements in the oxides. Write an equation for reaction of phosphorus with an excess of oxygen. 1 mark recall of an equation. P4 plus 5O2 arrow P4O10. They, for some reason, really like to include this equation. I've seen this come up at least twice, maybe 3 times. They really like this equation, so if you're not going to learn all of them, please learn the reaction of phosphorus with excess of oxygen, because they really like to include this. P4 plus 5O2 to form P4O10. And then it says describe a test you could carry out in a test tube to distinguish between sodium oxide and the product in question 6.1. So the product is phosphorus oxide. So the test to distinguish between sodium oxide and product is going to be add water, add litmus paper, and litmus become blue with sodium oxide and red with phosphorus oxide, so you can distinguish between them, because you know phosphorus oxide is red and sodium oxide is blue. 3 marks. So add water, add litmus paper blue with sodium oxide and red with phosphorus oxide. 3 marks. Then it says state the type of crystal structure shown in silicon dioxide and a sulfur trioxide. So in silicon dioxide it is giant covalent, or you can say macromolecular / giant covalent, and for sulfur trioxide it's just a molecular, simple molecule. Explain why silicon dioxide has a higher melting point than sulfur trioxide. That's a really nice question. Giant covalence got strong covalent bonds between molecules, whereas this only has van der Waals, so therefore covalent bonds. Yeah, very nice question. Covalent bonds between atoms in silicon dioxide. Van der Waals forces between molecules in sulfur trioxide. And obviously it might seem common sense, but you should know it. You should state it. Covalent bonds are stronger than van der Waals, hence covalent bonds take more energy to overcome. So covalent bonds are between atoms of silicon dioxide. So 2 marks for just stating this, the bond. So the intermolecular forces, covalent bonds between atoms of silicon dioxide, van der Waals force between molecules of sulfur trioxide, and then covalent bonds are stronger than van der Waals, and that's not it. Therefore, it takes more energy to overcome because the bonds are stronger. Therefore, silicon dioxide has a higher melting point than sulfur trioxide. Or you could say van der Waals take less energy to be overcome, so therefore sulfur trioxide has a low melting point than silicon dioxide, and therefore silicon dioxide has a high melting point. Write an equation for the reaction of sulfur trioxide with potassium hydroxide solution. So sulfur trioxide, SO3, plus potassium hydroxide, KOH, to form KHSO4. SO3 plus KOH to form KH. SO3 plus KH from KHSO4. That's 1 marker. Write an equation for reaction excess of magnesium oxide with phosphoric acid. So MgO plus H3PO4 to form Mg3PO4 squared plus 3H2O, and this is gonna have 3 behind it. It's gonna have 2, 3MgO plus 2H3PO4 arrow Mg3PO4 2 plus 3H2O. And then it says draw the displayed formula of the associated acid formed when sulfur dioxide reacts with water. When sulfur dioxide reacts with water, SO2 plus H2O plus H2O to form H2SO3 because you got H2SO3. So the formula, displayed formula, well, let's think about it. It's going to be S double bond O, and because it's not H2SO4, it's going to have a lone pair of electrons, and it's going to have OH, H2SO3. And this could be in brackets. And that is the end of question 6.